can remind us? Oh, what did I do? Who can remind us what the Pythagorean theorem is? Yes.
A squared plus b squared equals c squared.
So don't forget that the Pythagorean theorem is a squared plus b squared equals c squared. To simplify, leg squared plus leg squared equals hypotenuse squared. And this is only in a right triangle. The hypotenuse is always across from the right angle. So just a little recap of yesterday's lesson. I don't know what to say. All right, so let's look at the next slide together. Suppose that a city in which you live has a system of evenly spaced perpendicular streets. What does perpendicular mean? Not just intersecting, more detailed than that. They do intersect, but at what? A right angle. So think right angle. I know there's not a lot of space there. So when you think perpendicular, they intersect at a right angle. It's more than just intersecting. So suppose that a city in which you live has a system of evenly spaced perpendicular streets forming square city blocks. The map below shows you your school, your house, which is located 2 blocks west and 5 blocks north of the school, and your best friend's house, which is located 8 blocks east and 1 block south of the school. How many blocks would you have to drive to get from your house to your friend's house? Draw a path that you would drive and calculate the distance. So think about this. Go ahead, you cannot cut through, if you're driving, remember this, you cannot cut through a neighborhood. These are your streets, okay? These lines are your streets. There are probably other people's houses going this way. You must drive along streets, right? Do you understand that? So with your partner, drive from your house to your friend's house. Try to take as few turns as possible. Try to take as few turns as possible. So drive from your house to your friend's house. Draw a line. No, you can't. You would be driving through people's houses, Lindsay.
You didn't really fix that. I was going to say and drive through your house.
Oh, I'm glad that you would drive through other people's houses.
You have to connect home?
No, you're good. Just count and then figure out the distance. So each square is a unit. So calculate the distance after you do that. Go ahead and calculate the distance. You can talk to your partner. And you're only going from your house to your friend's house. I'm hoping that you didn't keep going like 1,000 turns. You should have just gone down and over, but or over and down. Or not through people's houses yet. So hopefully you drew something like that. Calculate the distance. Figure out how far you've traveled down and over or over and down. Each one is called a block. That will be our unit, a block. You can talk to the people around you. It's okay. Yeah.
Why is the house in the middle of the road?
It should be like on a corner, but it is what it is. That's so Lindsay can drive through it.
I get my license in September.
Oh, God. So you go down or over, depending on where you are, 6 blocks, right? You guys see that? How many do you go over? So how many total blocks do you have to travel? So 16 blocks. Okay. So go ahead and get that copied down and then flip to the next page. Lindsay's going to like this one. Don't worry, guys. We've got this. Okay, you're going to discuss this with your partner in just a second. What if you could use a helicopter to fly straight from your house to your friend's house? No longer driving through people's houses, but above them. Draw your path that you would take. Go ahead and draw the path you would take. If you want to use your folder or a ID or something of that nature for a straight line, go ahead and take it out. If you want to I would prefer for it to be straight, but it's your notes, not mine. So, you know, if it was like on something you were turning into, we probably should use a straight edge. What?
Basically, you made this wrong because if that's your house, we're still driving through it.
Okay, I got it. Okay, hopefully that means you did the shortest path, which is that slanted line there. So we're going to establish a coordinate axis system using the school as the origin of your house and your friend's house. So I'm going to use a separate color here. And we're going to use the origin being the school. So it'll look like this. So that would be the point 0, 0. So what would be the ordered pair for my house? What would be the ordered pair for my house then? Abby?
6, negative
Be careful.
3.
X comma Y, not Y comma X.
Oh, negative 2.
I have negative 2, 5.
Oh, sorry.
1, 2, 3, 4, 5. Does somebody else see negative 2, 5? Okay, so the house is at negative 2, 5. Remember, it's always X comma Y. So the house, I should say your house, negative 2, 5. What is your friend's house at? What is your friend's house at, Olivia?
8, negative 1.
Very good. All right, so how could you use the coordinates to calculate the straight line distance from your house to your friend's house? What could we do to figure out the straight line distance? So talk to your partner. Discuss it with your partner for a second. What do you think you could do to figure out this distance? What could you do? Carmichael, you can talk to Lindsay and Hayden. Lindsay is a nice, just so you're aware, she is. Harmony, what did you and your partner discuss? What could you use? You guys learned about the beautiful Pythagorean theorem yesterday. Thanks to Pythagoras. That's who named it, Pythagorean theorem. He was a real guy, Lindsay, and you just laughed at him.
Okay, he was.
I don't even know what to say to him. He told me I called him the wrong name when I called him the right name.
She's talking about you.
Oh, it was Devin. I got it. Okay, so we could draw that triangle in. So then we know that this is the point, negative 2, negative 1. So if we look at the x coordinates here from negative 2 to 8, what's the distance? So what were you about to say?
I was gonna say 6.
You want to say 6, but why is that wrong? I'm glad that you know that it's wrong.
That's -2.
It's not just 2, right? We're not going from 2 to 8, which would be 6. You can see that there's 8 spaces here, right? How many more spaces are there? 2. So the distance there is 10. Do you understand why?
Oh, yeah.
Okay. So horizontal distance, you look at the x's, because the x-axis runs horizontally. For vertical distance, you look at the y. So what is the distance from 5 to -1? 6. Good. Don't say 4. Remember, you have to go a whole 5 to get to the axis and then another one. So that one's 6. So from there, we can use the Pythagorean theorem. Are you okay, Conway?
I thought 6 was A.
It doesn't matter which order you do it in. A and B can be switched. Either leg, it doesn't matter which order you do the legs in. Addition is commutative, so it really doesn't matter. Meaning it can be switched. So 10 times 10 is 100 because you follow order of operations. 6 times 6 is 36. So that's 136 equals c squared. So then we do our factor tree. And we're taking the square root. Hunter, what is something that goes into 136? 68 and 2. Whenever I can't find something and I know it's even, I always divide by 2. It's the easiest thing to do. Iku, what goes into 68?
34.
Emma, what goes into 34? Good, and we are done with that factor tree. Found my group of 2. So I take 1 out of there, and 2 times 17 is left underneath. So I have 2 square root 34 equals c. So my distance is 2 square root 34 blocks. Sorry, I forgot the unit there. With your helicopter, not your car driving through houses. All right, so what questions do you guys have there about this one? Because we're going to see how the Pythagorean theorem relates to the distance formula now. Because those two go hand in hand. All right. So how do you find the distance when you aren't given a coordinate plane? So sometimes you're not given a coordinate plane. Sure, you could plot the points and draw it, but what if the numbers were like 1,000, 2,000 and -2,000, -1,000,000? You're not going to want to use a coordinate plane in that situation, right? Those are very big numbers. So we need to know how to do it when that's not the case. So here's how this works. The Pythagorean theorem is a squared plus b squared, or a squared plus b squared equals c squared. D stands for distance. This means, well, let's just label everything here. This little triangle here means a change. So this is change in x, so it's a change in the x coordinates, and this one is a change in the y coordinates. So if you're looking over here, this thing is the same thing as delta x, and this thing is the same thing as delta y. That's how you would figure it out. You look at the change in the numbers, so you subtract them, And distance is always positive. That's where that absolute value comes in. So those lines are absolute value because distance is always positive. Okay, so Mrs. Herbig, who also teaches geometry right across the hall, she told her kids yesterday when they were talking about distance, my cross-country kids sometimes run the opposite way around the track because in cross-country you don't just run one way, you turn lefts and rights. And so she asked the kids, when you're running the opposite way around the track, does that mean they're running a negative distance? Just because you're running the opposite way around the track? No. I always use the example too. When you go from home to school, it's a positive distance. Just because you're backtracking and going back home, are you going a negative distance? Does your car automatically go backwards because of that? No, reverse doesn't do that. Not anymore. So anyways, my point is, your distance is always positive. All right, so when you do a change in x squared plus a change in y squared, this is the Pythagorean theorem. The property of absolute value says that it's always positive, but when you square it, isn't squaring always positive too? Yeah, so it's all good there. And we know that if you take the square root of both sides, that will get rid of the square on the d there, leaving us with the distance formula. So this is called the distance formula. I didn't think I spelled coordinates wrong. And this is the distance formula. So when I say the distance formula, this is the distance formula. And I'm excited about it, that's why I put an exclamation point. I love math. You know, so if that bothers you, I'm sorry. So we're going to find the distance from 2, 3 to 8, 7 using the distance formula. So to do that, the first thing I would do is determine your change in y's and your change in x's. I would write this down. I know it's more work, but it will help you in the end. I know you guys hate when it's more work. Okay, Helena. A change in x. What is the distance from 2 to 8 if you're thinking about a graph? 6. If you can think of a number line, you put 2 here. 1, 2, 3, 4, 5, 6. Later is 8, right? That is a distance of 6. Austin, how about my change in y coordinates from 3 to 7? Yeah, if you go from 3 to 7, that is a change of 4. You don't have to do the number lines, but some of you are going to struggle when you go from negative to positives, okay? So if you do need to use the number lines, that's why I'm doing them off to the side. I'm okay with it. If you don't need to, I'm okay with it. You need to be where you're at. So we plug into the distance formula from there. So distance equals the square root of the change in x squared plus the change in y squared. Yeah.
Why did you go from 2 to 7 and then 3 to 7? Isn't one of them supposed to go to...
I went from 2 to 8. This arrow's just not making it all the way. I think that's what's confusing you. I didn't make it all the way to 8. There you go. Is that what was confusing you? It is 6. I just didn't draw my arrow very well. Is that better?
Yeah.
Okay. So we plug in. What did we get for our change in x? What did we get for change in x? So we plug in 6 there. What did we get for our change in y? So we plug in 4 there. Order of operations says you must do exponents first. So it's PEMDAS. So we must square first. 6 times 6 is?
36.
Good. 4 times 4 is? 36 plus 16 is?
52.
So then we have to try to simplify that. Hayden, what goes into 52?
2.
And? Perfect. Greg, what goes into 26?
13.
13 and 2. Very good. So I have 2 times 2 times 13. Can that be simplified? Cameron, what could that be simplified to? The radical. Yeah. 2 square root of 13. So our distance is 2 square root of 13, and I'm just going to put units. We don't have an actual measurement here. So, before we do a few more examples, and then I'm going to have you try one on your own as well, what questions do you guys have so far? Do you see how the Pythagorean theorem and the distance formula are related? Do you see how it's basically just taking the square root before you do anything? That's basically all it is. So that's what we're doing today. And you only have 3 more examples to go through. We have 15 minutes in class, so hopefully we can get through them and I can have you guys try one on your own so that you guys can show me that you understand it. Okay, so practice using the distance formula. You need to know this formula by heart, meaning it's not going to be given to you on a test. Do you understand that? Everybody got it? Okay. So find the distance between these pairs. I'm going to do example 2 with you guys right now, okay? And then I'm going to have you guys try to do example 3 on your own. So we're going to do example 2. I skip examples all the time. Don't have a panic attack. It's just I prefer doing certain examples. So the first thing I would do is find the change in x and the change in y. So Carmichael, the change in the x coordinates from -2 to 4, how many units have you gone? Perfect. And just to give you a visual of that, not that you have to do this, you have to go 2 to get to 0 and then another 4, which is 6. So that's why he got 6. Very good, Carmichael. How about y? What, Casey, how many would I have to go for y to go from 5 to -3? Yeah, you have to go 3 to get to 0, and then another 5 for a total of 8. So distance equals the square root of the change in x squared plus the change in y squared, taking the square root of all of that. So we substitute in. So that's 6 squared plus 8 squared. We follow order of operations. We must follow order of operations. Gabe, what's 6 squared? Daniel, what is 8 squared? So if I do that, 10 times 10, 5 times 2, everything's circled. What does that mean? What does that mean? What is my answer if everything's circled? Yeah, Olivia, right? Is it Olivia? What is it? It's a perfect square. Everything's circled. So should we have a radical in our answer anymore? No. We just multiply 5 times 2 together, which is 10 units. Okay, so I would like you guys to